So the basic technologies, plastic's been around for a long time, that's where it started, but there's a lot of metals and other human tissues, concrete, and there's just about anything you can lay down in a layer by layer manner can be 3D printed. But I've got a few examples on the table here of the technologies we run. Stereolithography, like I said, that's the first technology ever developed. That is this piece here. It's a UV curable epoxy, and we have a UV laser that actually cures a material in select areas. So everywhere a laser hit turns solid, everything else stays liquid. So very good on high detail. We've got both clear and white material on that one. SLS, select laser sintering. That's like this part here, and the keychains behind you. I wish everybody grab a keychain, by the way. So this is a powder technology. So it's a nylon powder that's then, go ahead and pass that around. That's then fused together with a CO2 laser. So again, anywhere that's hit by the laser turns solid, everything else stays loose powder. You knock away the loose powder, you clean it up, and you're left with a fully dense part. Fused deposition modeling, that's what you're seeing here. So basically it's just, like I said, a hot glue gun squirting out. Now our machine at the shop, much bigger, a lot of different materials. We have some very high heat materials. This is a nylon material that we can run in that. So good for tooling and fixturing. Surface finish isn't as good on FDM as it is some of the other technologies, but it's still a very good technology. Material jet printing, I've got one example of that. This is another liquid process that lays down UV curable acrylics, uses a wax support material, and then it cures that part layer by layer. So it's taking liquid and dropping it down from the top rather than bringing it up from the bottom like the SLA. Very good for very high detail. Hearing aid industry loves that, dental loves that. So if you have a small, highly detailed parts, that's a great technology for it. Color jet printing, I don't have any examples of that, but it's another powder process where it actually colors the binder as it goes. You get the same color spectrum as you do with any 2D printer. It literally uses HP print heads. It was developed at MIT. It's really good if you need a full color model. We're doing hundreds of little tenant machines for a tenant company because they're going to use them for handouts to their dealers and key customers and stuff. So handouts, trade show displays, that kind of thing. Really good for. A company we share space with makes 3D printed urns. You might have heard about them on the news, Foreverance. They use a 3D printer. They design up a special urn just for you, however you want it, and they 3D print it for you. Some of the things that really excite us about the future of 3D printing is new materials that are coming out, new technologies. The technologies themselves are really expandable as far as what materials you can use. They're just different heat settings, different laser settings, and there's a world of different materials that can come out there. As some of the key patents expire, then that's going to open up the open source community to come up with even more materials, which is really great. Software advancements, a lot of the key players in software are tailoring software just for 3D printing. So the design for additive manufacturing and 3D printing is going to be much easier in the future. And then near net shaped metal parts. I really like this one. You basically create a metal part that's about 80% done, and aerospace is really going to love that because now they don't spend 80% of their time roughing material away, and they're not wasting material. They're only machining what they need. And one thing I did want to bring up, I messed over the beginning. If you're interested in 3D printing, there is a great guide on 3dprintingindustry.com. So you can download it as a PDF. It goes through the entire history, all the different types of materials, all the different types of technologies. A lot of what you saw here was borrowed from that. Their website is really good if you want to follow somebody about 3D printing. I highly suggest to follow them on your your favorite social network or email newsletter. But that PDF guide has got a lot of really good information in it. So if you have questions about 3D printing, I'd start with their website and their guide to 3D printing for sure. So any questions about what you see here or what's going on or anything? Or
what's the coolest thing you've ever printed?
Coolest project we've ever been involved in was this one here. So we work with ladies that create facial prosthetics. Now they came to us because they had a different patient that just could not go through the impression process they normally use to get a working model off of. But everybody in that situation has a CT scan of their injured area. So in this example, this is a 6-year-old boy. This is the ear he was born with. So they're working on a prosthetic ear for this boy. Well, not only do they need to know how the ear needs to be shaped and work off of this, they need to know, the surgeon needs to know where the bone structure is underneath to surgically implant the metal implant. So we came up with this. We came up with right off the CT scan data, we were able to separate out the skin from the bone and give them a working model to work off of, so they can make things easier for people out there.
That's fantastic.
Yeah, that's the biggest one we've done so far. Size limitations usually a different another question. Our biggest machine is 14 by 16 by 16, but we've done a lot of parts where we've sectioned them. So we've done huge parts in multiple sections, and we glue them up and ship one part. We do, I mean, it's just a wide variety of different things, everything from electronics to medical prototypes and end-use parts. And we did parts for Tesla because they're the Chinese New Year one year got them by surprise. They weren't properly planned for it, so we actually made parts for the cars to keep their assembly line going. They paid a lot more for the part, but keeping their assembly line going was more important than the cost of that one. So we find ways to get 3D printing to help. Any other questions?
A maker bought at Home Depot last week. That's interesting. When did they start doing that?
It's been a little while. Micro Center picked them up, and then so did obviously Home Depot. I don't know how the sales are going because that's a pretty pricey item for Home Depot, $2,500 or $2,600. And then, like I said, most people don't have the understanding of the CAD files and what it takes to actually the upfront work to get something into it. So if somebody buys a 3D printer and thinks they're going to plug it in, it's going to be like your coffee maker. They're usually disappointed. Yes, sir.
How big do they get?
How big do the machines themselves get? Our biggest machine is, it's about 10 feet tall, about 12 feet wide. So as far as build area, they're getting bigger and bigger. They're trying to do entire wing spars in one piece and stuff like that. So it really is a matter of, your imagination. Like I said, the parts themselves can be any size because we can section them and assemble them.
If you had a large animal skull, like about this size, would you be cutting it this way?
We would look at the best way to cut. So let's say it's an animal skull with maybe a couple horns on it. We would maybe look at maybe taking the horns and printing them separate and then assembling it. So every project is different. The aesthetics of what you're trying to do obviously is the most important. We wouldn't want to put a seam right down the face of what you're doing.
Would you be able to do something like this?
Absolutely. We actually have a example of that. There was we have an MRI scan, a full color MRI scan that we then 3D printed out in full color. But yeah, we can definitely scan this and then reproduce it any size you want.
Upper and lower jaw at the same time or separately?
You know what? Does it? It doesn't look like it comes apart very well.
Oh yeah.
Oh, it does. Okay, then it would definitely want to be separate, and then we could print those, and then we can connect them so it's all printed at once, or we can print them separate for sure. Okay. Absolutely. Make sure you grab a card anyway.
When you like after they're done, doesn't matter what do you use type like paint or things on the outside or?
Well, the green and the blue, you see that in front of you? Those were printed white, and same with the keychains here. So that's nylon, and then we dye it different colors. Okay. We can do the same thing with the SLA, the clear and the white SLA, and then the FDM, whatever color it is going in, it comes out. But to answer your question, yes, you can paint all this stuff. So, yeah.
So where does it melt? So this is solid back here.
Right at the tip. And you see where the material's coming out right there? Like I said, it's just like a hot glue gun where the tip is hot.
Just
the only hot.
Okay.
Yeah. That way
You don't have to worry about cleaning anything.
No, on this one, not really. No, you just keep things, let it cool down properly and everything. And then, you don't have to worry about it.
And if you scan something, is that different than needing a CAD file for it?
No, the scan is a CAD file.
So it creates a CAD file, so you don't necessarily...
More or less. The scan itself creates a massive point cloud. And then you need software that can translate that point cloud into an STL file, and then make sure it's all watertight and everything. So the money you spend on software can be significant.
when you say watertight?
That means if your CAD file has any holes in it, the software gets confused on what's an inside and what's an outside, doesn't know where to fill. So the health of the CAD file is also very important.
kind of a weird investing question, but you know, you got Stratasys and other companies like that, and,
Yep.
and they all have, they rose really high and then got hit because for whatever reason. What's the nature of the industry, and who do you think are going to be the players, and how does that fit in with what you're trying to do?
With what we're doing, we're a service bureau, so we're not connected to them directly. We just, you know, we like own a Chevy or own a Ford. We're not
Yeah.
actually part of them. But as far as how big they got, I think they got a little too big, a little too fast
Did they?
myself. 3D Systems is the other 800-pound gorilla, and they acquired everything they could. And I think that started to bite them because some of those investments weren't the best choices.
So not as many people buy them originally, but long term, it's kind of like maybe the fax machines were way back when. You know, nobody had a fax machine, then a couple companies did, and then everybody got
Right.
it.
And there's a lot of people looking for the next big thing in 3D printing and wanting to invest in that because it's so hot. But there's a lot of, you know, some people have their head in the clouds as far as what's actually possible with 3D printing and what's actually implementable and what's do people really need. Yeah, maybe you can 3D print a certain way, but is that really needed in the industry? Maybe not, maybe not. But and then speed is also a big factor. These aren't the fastest way to make parts in the sense that the production of a part could take longer, but from concept to finished part is much, much shorter because we don't have tooling and fixturing and programming. So there's people out there trying to greatly increase the speed of 3D printing. Well, if they're sacrificing part quality or part strength to get that speed, then that really doesn't do us any good. Because our customers need quality parts that are, you know, durable and function for a long time, not just sit there and look good. So I'm a little bit afraid of the speed. And when somebody says they can 3D print 100 times faster, well, is that really necessary? And what are you sacrificing to make that happen?
Thank you.
You see the
If I had,
combinations. I'm sorry, go ahead.
if I had something that was, say, this size, say a vertebrae,
Yep. Okay.
and I wanted it, and this was going to be 1/10 scale,
All right.
and I wanted to bring it up to full, would some of the detail be lost?
It depends on your original file. If your original CAD file has all the detail, it will be there when we blow it up. So yes and no. If you're going to have that scan, make sure you have it scanned in the highest resolution possible, knowing that you're going to blow it up and you don't want to lose detail. If you're going to make it smaller, you can scan it at a lower resolution because those small details aren't going to show up on the print anyway. So and knowing what you want to do with it when you go into it is definitely
And then I could add the detail onto the piece that came out for casting.
Oh yeah, absolutely. Yes, yeah. You can if you get a piece and you need more detail to it, you can absolutely modify it, put clay on it, whatever you want to do, and then yeah, you're right. That would be a good positive for your casting process.
Okay.
Absolutely.
You're working nylon and plastic today, do you anticipate being able to use other stuff or molding companies out there?
We definitely want to get into metals, but that's such an entirely different animal. We wouldn't have a metal machine in the same shop as a plastic machine because it's a completely different mindset. You need different skill sets, you need different support equipment, you almost need a machine shop on the back end to make those parts usable to your customers. So it's not going to be just a apply machine, it's going to be an entire division.
But that's the combination of additive and subtractive. They're seeing a lot of that. There's 2 or 3 companies now that are coming out with standard offerings that combine both
Absolutely right.
technologies.
Yeah, and aerospace is really pushing that because they're looking for ways to make parts faster and make geometry they couldn't make any other way. So yes, you're absolutely right. And we can produce metal parts and then give them to somebody, but somebody's got to do some post. 9 times out of 10, there's got to be some post machining done to those to make them, you know, really usable.
So the combination of additive and subtractive makes sense in a lot of cases.
It does.
Near net them and finish them with a subtractive technology.
Absolutely, 100%. Yep.
Yeah. Companies like EOS and some of those guys that are focused on.
They're focused on the additive. I think
Yeah, well, I mean, there's some people that have adapted that technology. They're not.
Right.
They're not.
The machine tool makers have kind of integrated in some.
Matt Sura just on the
Exactly.
on the frontage road down here uses an additive element to their subtractive.
Right.
Even they're a subtractive technology company.
That's almost like a welding kind of head additive process. You're right.
Mazak's doing it.
Mazak's doing it, yeah. And
Maury's doing it.
Yeah.
DMG.
they're all going to have to do it at some point because everybody's screaming for it.
You doing peak and things like that?
No, we do a material called Ultim 985, which is aerospace grade plastic, so it's very hard, very chemical resistant. So that's our best quality material there for heat.
But peak's got biostat and biocompat
Right.
elements to it.
Right.
That
Yeah,
are,
we're not doing peak yet, but and that's where the metals really help in the medical world, just because a lot of the titaniums and stainless steels that they're using are
How about bioabsorbables? You doing anything there?
We're not, no. That's kind of a specialty thing that somebody needs to spend a lot of money developing and everything like that. But yeah, that's a huge.
So
They're
you
already
can
doing that. But
Impregnate drugs and things like that in bioabsorbables and
the one story I really like is that they create a kid has a condition that his windpipe kept collapsing, and they have to rush him to the hospital every single time. Well, they 3D printed a support for his windpipe, and they implanted it, and it's biodegradable, like you say. So over 10 years, it'll just erode away, and then his windpipe will be strong enough. So that kind of thing, yeah, that's people way smarter.
and you mentioned tissue printing, so you print a substrate and again,
Yep, absolutely. Anything you can figure out how to lay down and add in a layer by layer fashion can be 3D printed. There's a guy in Minneapolis that 3D printed a castle in his backyard out of concrete. He just figured it out.
I saw that picture.
Exactly.
It was
He had to figure out
fascinating.
the concrete mixture, how he was going to pump it, move the nozzle around. Then he had to design it, and he had to do a lot of different things, a lot of trial and error.
So each of those pieces might have been something like this or whatever. What size printer would he have had?
He built a huge gantry that was bigger than the structure he was printing.
Okay.
So then he would print an entire room at a time, just grow, you have to do the entire layer at a time. So it's
You do.
Living room, front room, everything. And then move up to the next layer and then move up to the next layer.
I just don't get this. I just don't get it. I just love it. But
It's I'm sorry, it's about 9 o'clock, so maybe we can wrap up here if anybody has one last question, and then feel free. Tyler and Kate also brought bagels for us this morning. There's cold brew coffee from Black Eye Brew from Matt. That's best served cold, so drink it now, and then grab a seat, and we'll get things wrapped up. But if anybody has one last question for Tyler while we get a couple things organized,
It doesn't
feel
appear
free.
that it's using much material.
It's not. It's this is what is actually printing. So if you can see the lines in it, it's drawing fairly thin lines as it goes around. But that's the other great part about 3D printing. Is we're only using basically the material that's used.
Right, there's no waste.
There hardly any. Right. There's going to be some, but hardly any. Thank you.
fascinating. Great job, Tyler.
Thank you very much.
so much.
Hey, anytime. So we'll be around afterwards too if you have more questions.